So to start out with, first of all, in activity 1 on page 11, it is having us work with perimeter and area. So we're going to write an equation where it shows that the value of the perimeter is equal to the value of the area. We're then going to solve for x. And then once we find the value of x, we're going to use that to find the perimeter and the area of each figure. And in the end, we will go through and check our solutions by comparing our answers to perimeter and area, and they should be equal to each other. So as we work through this, we're going to go ahead and review really quick how to find the perimeter of a rectangle. Well, when you find the perimeter of a rectangle, you work your way around the outside of that rectangle. So if this is 3, there's an x, that's 3, and this is also x. So when I look at this, I can look at it kind of like we did when we worked through the the triangles back in lesson 2. We're going to go ahead and put together everything that's there. So here I'm actually adding all of those together. So when I look at this, I have 1x and another x. I have 2 x's, and then these together, my constant numbers, are 6. So I have 6 plus 2 x's for my perimeter. Now, to find the area, you do length times width. Okay, so 3 times x, well, that's 3x. Okay, so now we're going to review working to get x's to one side. So because here's my equal sign, and I already have 3x by itself on the right side, I'm going to go ahead and get rid of my 2x on this side. It'll save me some steps. So minus 2x minus 2x. I have 6 here, and on this side I have 1x. So 1x equals 6, x equals 6. So I just found out that x equals 6. Okay, so now I'm going to go ahead and I'm going to substitute in 6 where x is. And I can either choose to go to my equations over here and substitute in. I'm just going to do it on the picture on this one. So if I substitute in 6 where I had x initially in on these figures, change back to white here because it shows up really low. This is 6 and this is 6. If I go through and I do my perimeter, well, 3 plus another 3 gives me 6. Plus 6 is 12, plus 6 gives me 18. And I don't have dimensions on this, so it's just 18 for now. Now to do area, it's length times width, so 3 times 6 gives me 18. Now I'm going to check myself. Were my perimeter and area equal to each other? Yes, they were. Okay, so here I found out that x equals 6 and the perimeter and the area of this rectangle are both 18. So let's try another one. Same thing, we're going to go ahead and solve for x. So we're going to have to set up our equation first. So let's do letter D. Now this one has a fraction over here. And if you don't like to work fractions, you are perfectly welcome to go ahead and change that to its decimal form. So I'm going to review with you really quickly how to change a fraction to a decimal. It's all in the way that we read it. So as I read this as 5 divided by 2. So I'm just going to punch it in that way, 5 divided by 2. Now I'm comfortable it's 2.5. But if you're not, you might have to use the calculator. So now I'm going to go ahead and write that here, 2.5, which means this side over here is also 2.5. And the top up here is an x because it's the same as this one, okay? Now I like to do that because I like to see everything. Okay, so when I do my perimeter, I see 2 x's, and then I see 2.5 plus a 2.5, that equals 5. So I have 2 x's plus a 5. Okay, for my area, remember it's length times width. So it's x times 2.5 or 2.5. X is how you guys are used to seeing it when it's just multiplying between those two numbers. So now I'm going to go ahead and get my x's to one side. Okay, so right now, here's my equal sign. I already have 2.5x by itself over here, so I'm going to shift this one out. So you need to remember that if you are moving that front number and there is nothing in front of it, you have to think, right now it's positive 2x. You're not thinking the opposite of this symbol. You're thinking the opposite of what this is because you're taking the x with it. So right now it's positive 2x. We're going to say minus 2x or subtract 2x, negative 2x. Minus 2x. I have 5 equals 0.5 when I subtract x. Now I'll divide by 0.5. Divide by 0.5. Okay, remember this is not 5 divided by 5, it's 5 divided by 0.5. If you need to use your calculator, you may, but I know that when I divide this out, 5 divided by 0.5 is going to give me 10. Okay, and once again, just to review how to punch that in, oops. You're going to punch it in like this, 5 divided by 0.5, 10, okay? So now we're going to go ahead and I'm going to substitute in 10 where I had x. So this is a 10 now, and this is a 10. So when I do the perimeter, 10 plus 10 is 20, 2.5 and 2.5 is 5, so 20 plus 5 is going to give me 25 for the perimeter. Okay, and then when I do area, it's my length and my width, or length and width, but it's 2.5 times 10, that is also 25. Okay, self-check, yes, they did end up being the same answer. Okay, so let's try one more of those. Actually, no, we're going to move on to a more complex one. So you will work through the other ones there on page, what was that, page 11. You're going to work through B and C that are very similar to this. But for right now, I'm going to, if you want to pause the video and work through those, you can. And then you can check back with me on the answers to those too. But I'm going to go ahead and move on with a complex figure. So if you're wanting to work right now through B and C, go ahead and pause your video. Okay, so we're going to work with this complex figure. And the reason it's complex is because it's composed of more than one rectangle. So we're still going to have to think our way through the process here. When we do perimeter, it is still going to be the distance around the outside. So I'm noticing here that I have some missing side lengths. I'm going to change colors here. Okay, so I've got this side that's missing. Well, that's the same as this. So that's an X. And then it looks like I'm missing a side here because remember, perimeter is working its way around the outside. Well, that's the same as that one, so that's a 1. And then I'm missing this side here. So here's the thing, to get that one, the whole distance of that length there is the same as this. So that's 3. Here's 2 of it that I just cut off for that part. So that leaves this to be 1. Okay, so let me erase all of these dotted spots. Okay, so now we're gonna go ahead and do, when I look at the perimeter on the outside, and I'm just using the numbers on the outside, I see 2 x's. So I'm gonna go ahead and write 2x. Plus, remember we're adding all of our sides together. My numbers, well, I've got 3, 4, 5, 6, 7, 8, so plus 8 is equal to, now for area, you're gonna have to think in terms of, I really have 2 smaller rectangles, and in the end, I'm gonna add them together. So if I do the area of this smaller rectangle, length times width is 2 times 1 is gonna give me 2. Okay, here I would do length times width, 3 times x is 3x. And then I'm going to add these 2 together because I've added those 2 pieces. They've slid them right next to each other. So I cannot really add these numbers because this 2 does not have an x. So I'm just going to write it out as 3x plus 2, or you could have 2 plus 3x. It's up to you. Okay, so there's my equation. So now I'm going to go ahead and I'm going to work my way to get x's to one side. Now, I know a lot of you prefer to work with your x's on the left side. I'm going to have you step out of your comfort zone and work and try and start kind of looking at these for strategy. As I'm looking at, here's my equal sign, as I'm comparing these 2 x's, here's what I'm seeing. Both of them are positive. That's a good thing. So if both are positive, I want to get rid of the smaller one so that in the end I still have a positive answer left over. So I'm going to go ahead and shift my 2x out. Okay, this is just giving me strategy because I don't like to work with negative numbers if I don't have to. So that's why I'm choosing to move this x instead of the 3. So I'm going to say minus 2x, because right now it's a positive 2x. Minus 2x. Okay, and what that is helping me eliminate is having to have a negative x left over. So 3 minus 2 gives me 1x. I still have plus 2. And on this side, I still have an 8. So now I'm going to go ahead and get rid of anything that's with the x on this side, so minus 2. minus 2. I have 6 equals 1x. Oh, 1x equals 6. So I just found out that x equals 6. Okay, so now I'm going to go back in here, and wherever I have an x, I'm going to put a 6 in white. This is now a 6. And I'm putting that in parentheses so you don't think it's 36. Okay, so when we do perimeter, we're adding around the outside. So 6 plus 3 is 9, plus 6 is going to give me 15, 16, 17, 18, 19, 20. Now I like to go around like I did there, just so I don't accidentally miss a side. So I just found out that perimeter is 20. Hopefully I didn't mess something up there when I was adding in my head. Okay, so now when I do my area, okay, the area of this smaller rectangle we had already found was 2. And then the area of this bigger rectangle is 3 times 6, which is 18. Now we add these two together. 18 plus 2 gives me 20. Ooh, good thing I didn't mess up my addition in that perimeter. So once again, I can self-check. Yes, I did get the same answers. Okay, both of them ended up being 20. Okay, so you're going to go ahead and you're going to work through the other, I think there's 2 other problems there on page 12 that are working with complex figures. So you're going to have to break it down. If you need help, rewind and watch from the very beginning of this letter E. Okay, so we're going to go ahead and